So the NoSQL has come for multiple reasons. Okay, the first is like not only SQL. The reason is the data which are in SQL are pretty normalized, as we talk about, right? You have a column-based architecture where you put each and everything in a column and then do it. If you need to get those data or do something, you have to do a lot of joinings, right? So you have table 1, table 2, table 3, and you need this is user table, this is product table, this is delivery table. If you need all this information, you have to do a lot of joins, do a lookup, get me this, get me that, and all these things, right? Not all the use cases needs these kind of things, right? Not always you need. You might need sometimes that, okay, I want just a flat data. I don't care about the, at individual level how it is stored, and I'll not even be updating those data so frequently. So I want the data to be stored in the flat. Okay, and there is a concept of using that also in SQL, that is called the blob and clob. That functionality is there, which basically stores the binary large object, and clob is also binary object. So both blob and clob are kind of a data store where you can store the big chunk of data inside that, and you can retrieve it. But it is not as highly performant as NoSQL does, and also it doesn't provide other aspects of the availability and horizontal scaling. So all of these reasons has kind of brought something concept called NoSQL, and NoSQL became highly popular with one tool, one software, which is called the Cassandra, which was developed by the Facebook. Okay, so Cassandra came in because Facebook was launched with PHP plus MySQL. If you have guys watched this movie, The Social Network, right? Mark Zuckerberg's Social Network movie, or you have read about like how the MySQL started. The Facebook started. They started with PHP plus MySQL, and eventually they started seeing that a lot of problems in scalability and performance, and they started thinking that why do we need SQL databases all the time? Why can't we do a flattened out? Why can't we make a database where it is a very good optimized for read? Why can't I develop something? And then they started something called the Cassandra. So Cassandra made it kind of a NoSQL as a quite beneficial application to use in terms of storing verbose data or flat data, and also make it more available. Okay, so they need more and more availability. They didn't care much about the consistency. We'll talk about why. They cared more about availability, make it more optimized, so that will be available for the user just to look around and do this. And they needed lot data to be ingested. So not only SQL is good in those regards. So like ACID for SQL, we have something for NoSQL. Do you know the name of it? Like ACID, there is something. What is the ACID's opposite?
Base.
So like we do talk about ACID in SQL, we talk about base in NoSQL. So base means the first is called the basically available. The system guarantees availability. Okay. Next is soft state. So it can change over time even without the input. So which means that even though you don't get the input, it can change. So that's what the eventual consistency means. Okay. And then of course, the more. So it can become a consistent over a period of time, but it doesn't, always guarantee you the consistency, because if you're going for the higher availability, you will have to be compromising on the consistency. It could be that you have done an update on one node and it hasn't been reflecting on the other node because there is a problem in between, the communication problem, or it could be that it hasn't been able to write to that particular node. Okay, so this was BASE means. There are various types of NoSQLs are available in the market, right? So you have key value, document, columnar, which is nothing but the Cassandra. Document based is MongoDB, right? Redis comes in that picture, key value, and there are also, you can use HBase also as a use for that key value as well, right? So you can use these kind of NoSQL structures, I know NoSQL applications for doing more and more writes. So like Cassandra is famous for write optimize or write heavy tool where you can do a lot of writes. Okay, document based is like if you have a way too many flat JSON where you want to have been stored like XML or JSON or protobuf kind of a huge data set, you can use the MongoDB. If you have a data like key value, you can use the key value. Then also there is one more which is called the graph, right? Graph database. So you can have a graph related database. Then there comes a time series database. Time series database like a graphite. Okay, so there are various types of software. This comes, and you have in terms of MongoDB, you also have the couch based DB. You have Amazon's DynamoDB. Okay, so there are way too many types, and we use it for various purposes. Like if you have to do a lot of writes, make it more available. I'll talk about the CAP theorem that will be basically be applicable to these things and how it becomes more and more available. And also we'll talk about little more about the Cassandra, how it works and all that. Okay, so the problem which was there that if we are making it more and more available, we started seeing a lot of challenges in terms of making it more scalable and all. Right, now let's see that how do we achieve. So Cassandra, right? So Cassandra is one of the solutions where we have something like a multiple read nodes or write nodes, whatever. See, they don't differ in, and each will be interconnected to each other. So it's like a two-way. Okay, so you can basically connect to any of the node. And they are called the peer nodes, and they use something called gossip protocol.